Traditionally, utilities companies have hired line workers to install sensors. These operations can be very dangerous and are typically very expensive. We have developed an unmanned aircraft system to help address this issue. Our drone is capable of mounting and removing a sensor from a power line. The system is made up of 3 parts that work together to complete the missions. The latch mechanism is designed to secure the sensor quickly to a power line with a high clamping force. Supporting hardware is used to secure the sensor to the drone and to monitor the mounting and removal processes. A user interface allows the pilot to view the mounting and removal processes in real time. It also provides the pilot with critical controls and information. When mounting, the latch and sensor are flown to the power line. A trigger lever is activated when the latch contacts the power line. The servo motor turns a gear, generating the clamping force. The sensor is released from the drone, and the drone flies away. For removing the sensor, the drone approaches the sensor and pulls up on the release lever arm of the latch. The ratcheting mechanism disengages and the sensor is pulled away.
To test basic functionality, an outdoor flight test was conducted. To begin, the user turns on the drone and connects to a custom user interface. The sensor is then loaded into the drone. By confirming that the live view of the latch is functioning, the drone is primed for flight. Once configured, the aircraft is ready for its mission.
Flight tests were conducted on a mock power line. Here, the pilot arms the latch servo motor and the latch gear begins to rotate. The current supplied to the latch motor is monitored in the user interface. The pilot uses the live camera view to help guide the sensor into position. The latch is tightened. The user opens the sensor grip and the drone releases the sensor. To recover the sensor, the drone is reconfigured with a retrieval wire loop. The drone approaches the sensor and the wire loop hooks the release arm of the latch. The drone pulls up, releases the sensor, and flies back to ground with the sensor.
Additional testing was conducted to simulate high power and high wind environments. From high voltage and high current testing, it is predicted that this system will be fully functional up to 26 kilovolts and 4,000 amps. From testing the friction force of the latch, it is predicted it will be able to withstand winds of up to 65 kilometers per hour without sliding on the power line.
With drones increasingly being used for visual grid inspections, a logical next step is to use these flying robots to perform work directly on power lines. Due to our system's close proximity with high power conductors, the technology we developed has the potential to be used beyond its current application. This project highlights the initial steps towards utilizing drones to deploy sensors on power lines. The design further advances technology towards reducing costs and improving safety through the use of unmanned aircraft in the transmission and distribution industry.